World's top astrophysicists, Dr. Berdyugina was here. She is looked at as a world expert in how the universe works and in exoplanets. She does TED Talks and is well known in astrophysics circles.
Out there in the universe. And the Earth is just one of them. In this universe, we are really tiny. We put Earth in the center of the universe. Then we realized something wrong with it, so we put the Sun in the center of the universe. Again, it was a little mixed. We put Milky Way in the center of the universe. Not so bad. And we found out in the end that there is no center of the universe. Our planet is just a single blue dot among billions of other stars and billions of other planets. We use these plants as prototypes of photosynthetic organisms in the universe. And then we build models for alien lives, how they could look. And when we puzzled with this question, how aliens can look like, we actually find answers in the backyard. When we detect life on other planets, we will understand and learn that we are not alone. And we are not special.
I wanted to interview her, but how? I thought about it and I created an alias, David Howard from Oxford University Media Society, and created some online material supporting this front. After some well thought out, tricky and delicate emails, I got the appointment, and with the backstory that I was collecting information for young students at Oxford. As I waited in the lobby of this advanced university astrophysics centre, I could see that this was a business, with funding, hierarchy, secretaries, etc. Now before we get into the interview, for those new to the channel, know that gravity is just a theory, and my blog in 2015 explained the errors with gravity, and that it can be explained away by density and buoyancy. This blog had over 50,000 views, with not one person debunking it. Also worth knowing is that in 1931, a book called 100 Authors Against Einstein was published in German, and is in the description. This shows 100 scientists stating Einstein was leading science into pseudo-mysticism, abstraction, and speculation. It was crushed by mainstream science. Also know of the Dunning-Kruger effect, a cognitive bias in which experts mistakenly assess their cognitive ability as greater than it is. It's related to the cognitive bias of illusory superiority, and also comes from the inability of people to recognize these experts' lack of ability. Obviously in this interview I couldn't say what I really wanted to early on, as I didn't want her to walk out. I wanted her to cover more subjects and get more answers. So take a seat and buckle up, and this gets more interesting as it continues, and presents a big key, one the truth community has needed for a while. Okay, let's play. Yeah.
Okay. And this doesn't go to unedited somewhere. You will edit this?
Yeah,
somehow?
sure. You can swear or go to the toilet or whatever, it's fine.
Okay.
Sure. Hello, Dr. Berdyugina. If you could just spend 1 minute or 30 seconds explaining who you are and what you've done.
Yeah, so I grown up in Russia. I fell in love with astronomy, first with physics and then with astronomy. And I realized that I want to understand the universe. I cannot live on Earth without knowing what's above my head. I just felt like I need to know. I went to the university, studied astrophysics and mathematics, lots of programming, because when we were studying astronomy, we were told that astronomy is not just science by itself, it's very interdisciplinary. So to be an astronomer or astrophysicist, you need to know physics, mathematics, programming, and I must tell right now, lots of social skills.
Yeah, sure. Great. And move on to your your subject, exoplanets. What percentage surety do you have of there being other Earth-like planets? Are you 100%, or are you 80%, or are you 65%, or do you change each week?
I think we are 100% sure that there are planets like Earth out there.
Okay.
We are, say, I don't know what's the error bar, like say 80% sure that there are 30% of those planets
habitable.
No, Earth-like. Yeah. That out of all planets in the galaxy, 30% are like Earth. This is our like estimate.
Yeah.
But we're 100% sure they're there. It's just the question now in this science: how many, and how close they are to the Earth. So that is the questions. But this question, if they're there, we already solved. It's there.
Okay. With these people I was speaking to, let's pick the TRAPPIST-1 system, the one that got into the media. This was the image, and I believe with photomy and other ways of measuring, I think you measure the brightness, the electromagnetic spectrum, and spectral changes. Then this turned into this colourful planets with volcanic activity, water content. How do changes in electromagnetic activity and spectral activity and brightness, such as the image in the bottom left, how does this turn into all this information about volcanoes and water and size and atmosphere?
These are just models. All these pretty pictures of exoplanets, they are all artist impressions.
Sure.
Yeah.
Do you think that's misleading to the public?
Yes, I do. It's pretty beautiful, and if you are not in the field, like a public, you look at this, it's like, wow, this
they found this.
Yeah, they found this, and it's absolutely misleading. I disagree with this. Yes.
Do you say it's 100% these planets exist? Do you think it's a leap of faith to say, okay, I measured some electromagnetics, I measured some brightness changes, I got some spectral graphs of data. Do you think it's a leap of faith to say these are habitable Earth-like planets?
We do. Well, it's still science. No, I don't think it's leap of faith completely. Yeah. So it's still science. Indeed, in astronomy, we just analyze mostly data and mostly electromagnetic. Right now, it's gravitational and particles, of course, but mostly it's electromagnetic waves. Yeah. And that light, electromagnetic waves, contain a lot of information. We learn about composition of the sun, not going there, because we analyze the light of the sun through spectroscopy, polarimetry, and so on. Yeah?
Sure.
So we do the same with stars, and we do the same with other planets. We see very little specks on our
which I've shown down here.
Yeah, exactly, on our detectors. But we can analyze this to get chemical composition, for sure, and we detect water, and we say, yes, look, there is a signature of water. We know that signature in the spectrum is water. So there is water.
How does that spectral information turn into water?
Because molecules in the atmosphere, for instance, in our atmosphere, there is molecules of water evaporating from the ocean. They specifically interact with the light coming from the sun. They absorb a certain...
So you're getting the same data?
Yeah, you get like imprint of molecular presence because molecules are rotating and vibrating, and that requires energy for them. So for molecule to exist, it needs always absorb energy.
Okay. How can you be confident of the accuracy when you're trying to measure things 230 trillion miles away? How can you be sure of the accuracy when you're going 232 trillion miles away with a little instrument on Earth?
Yeah, that is quite amazing probably to understand, but this technique of spectroscopy is basically distance independent. If you see imprint, of course the problem is to collect enough photons. So when you go further away...
Light photons.
Yeah, light photons. You need to collect them enough in order to see the defect due to water absorption, what we call. And for that, for instance, if defect is 10% relative to the total flux, then you need, let's say, at least 100 photons to detect it, you know? So that it depends on your detector. Let's say you need 10 photons would be probably not enough to detect it. You need more, maybe thousands of photons.
The more data, the more patterns you can
exactly.
get.
But it's really distant independent in this case. So if there is water, it doesn't matter is it here or 1,000 kilometers or in the lab.
So what would be your number one proof? You're at a dinner party, someone says, what's your number one proof, scientific method of Earth-like planets existing in the galaxy?
So far, we know they exist through transit techniques. This is our... these are not, like you have a curve there, this is not a direct detection of a planet, it's indirect, means that the planet transits across the disk of the star and then we see this dip. This is not water, this is just a presence of a planet. And by amount, how big is this dip and how much it lasts, we can say whether it's small planet, big planet, on which orbit it is, you know. And through that we know that there are these kind of small planets, yes.
Okay, great.